One of the most challenging tasks in NLP is to extract information and relationships from text. And that's what we'll be doing in this video. And our challenge, however, is not to analyze a modern text, but a fantasy story that is set in the 13th century. What's up everyone? Welcome to the second video in this Witcher project series where we'll be reading through all the Witcher books and create a social network of characters with the help of NLP and network analytics. At the end of the video, we have created a network graph of all the characters and be able to answer several questions. What are the most important characters? How their relative importance developed throughout the series? And what are the main communities of characters that form this social network? Now, let's go to our project. We have created this project in the last video, so in case you missed it, you can check it out here. To continue with this part of the project, we'll need to install some extra packages. So we'll install Spacy, which we'll be using for the text processing and the named entity recognition task we are going to do, and another library called NetworkX for analyzing the networks, also Byvis for network graph visualization. Spacy is free open source library for natural language processing in Python. Another widely used library is NLTK, which is more research focused and it provides a lot of different algorithms. However, Spacy uses mostly the best and the latest algorithms, so it often results in better performance. And of course, there are also tons of other libraries that allow us to do all kinds of different things with text, but for our purpose today, we'll be using Spacy. Now let's create a new notebook called Extracting Relations and import pandas, NumPy, Spacy, and DisplayC module for visualizing the entities later. We'll also import NetworkX and Matplotlib pilot for some plot settings later. And we also need to import the English language model for Spacy. And we'll load this model into a variable called NER, named entity recognition, but you can of course choose other names as well. This project might seem a bit complex, so let's first briefly discuss our strategy for our mission. There are several methods for extracting relationships from text, from simple rule-based methods to advanced deep learning models. However, I found that the deep learning models that are currently available are often trained on a specific dataset, for example, research papers on drug discoveries. So they are not really suitable for a fantasy novel. As I'm not an NLP expert, in the end I decided to go for a simple baseline model that is based on named entity recognition together with some custom rules as follows. First, I tokenized every book into a list of sentences and then labeled each sentence by the name of the characters appearing in the sentence. Second, I defined a window size of how far two sentences are apart from each other and assumed that if two characters are mentioned in two sentences within this window, then there is a relationship between them. With named entity recognition, of course, we'll recognize all kinds of entities from text, from person's name to organization's name to location and so on. And the good thing is we already know the names of all the characters from the books because in the last video we have scraped them from the Witcher wiki, so we can easily automatically filter out all the entities that are not characters, such as the names of a monster or a kingdom, for example. But if you like, you can include them for extra analysis as well. Okay, I found a GitHub repo that has 8 books of the Witcher novel in text files, so I'll go ahead and download this Git repo and I'll just copy the text files into a data folder in my project. So we have the 8 books here. And now going back to our notebook, we're gonna import all the text files. We first import OS library and then we can search for all the files that are in the data folder. I like using scanner for this, but you can also use other methods as well. So let's check it out what this list looks like. We have all the 8 books, so this is perfect. Okay, now let's pick the first book and do the analysis on this book first. Later we'll iterate over all the books in this this list. So to get the text from the book file, we'll open it and read it. It's just really much like natural language. And then we'll call the named entity recognition object that we just defined on this text file. Now we can visualize the identified entities with DisplayC. Let's first do this for the first 2000 characters of the book because the book is obviously very long. We can see that Spacy does quite a decent job at identifying some named entities. For example, one of the main characters in the series, they are ordinal or cardinal kind of words. And so, yeah, so this looks quite impressive. Now, the next thing we'll be doing is to load the character data frame that we created in the last video. So I have saved this data frame in a characters.csv file, and now we will read in this file. Some characters have the bracket next to them. That is to give some extra information, I believe. However, we don't want them in our character names because later we will have to match those names with the names that are actually appearing in the books. So I'll go ahead and remove these brackets and the text between the brackets from the names. So we'll import regular expression module and we'll do an apply function here on the character column. So for each row in this column, we will substitute this pattern. So the pattern here includes all the things that are between the round brackets. We will substitute them with an empty string. And if the pattern is not found, then we'll just simply return the original value. And we also create a column for the first names of the characters because sometimes in a text, a character might be mentioned only by the first name. For example, Geralt of Rivia, the hero in the series, is only mentioned as Geralt. So we will just take the first name here and it might be useful for our analysis. So here we will basically do an apply function on the character column and we will use a lambda function that is to basically split the string into different words and then we only take the first word, which is the first name of the characters. Now we just print out the character df again to check if everything works. And yeah, now we see that we have the first name column and we don't have the brackets anymore, so that is perfect. Now the next thing we want to do is to go sentence by sentence through the book and create a list of entity for those sentences. Now we'll first create an empty list called send_entity_df because we will convert this list into a data frame later anyway. And then basically for each sentence, we'll create an entity list that stores the entity for all the entities that are in the sentences. Spacy has done all of this for us, so we are basically doing some bookkeeping. And then we will just need to append the sentence together with the entity list into the send_entity_df. Now, if we convert this list into a data frame, voila, we have a list of all the sentences together with the entities. That is very nice. The next thing we want to do is to filter out all the entities that are not characters. And to do that, I will create a function. It's a very little function called filter entity. So basically, it will take the entity list and the character df, and then we will return a list of entity only if the entity belongs to the character df character column or the entity belongs to the first name column. So by doing this, we will effectively only keep the character names or character first names in the list. So let's check if this function is actually doing what it should do. So I'll just randomly pass a list here just to test the function. So if we run this, we see that, yeah, only the elements that are character names are kept in the list. So that is good. And so now we can just apply this function. So we just need to do a simple apply function here. We also see that many sentences don't have any named entities, so we can just remove them. Okay, so far so good. We see that Geralt of Rivia and Geralt are identified as two different entities, which is not good because later in our analysis we don't want to create two different characters for the same character. So I will just only take the first name of the characters just to be consistent. So I basically just call a lambda function here to only take the first name of the characters in the entities column. Okay, now the coming step is a crucial step for our project because now we are actually extract relationships from the text based on the characters that are identified in the text. As discussed earlier, we will now specify a window size. I'll just for now use a window size of 5 sentences. So we'll basically do a rolling window through the text and identify all the characters that appear in the same window of 5 sentences. So for I in range of the last index of the Centrality DF filter, we'll create an end I. So the end index of the window would be I plus 5, right? It's very simple, but we have to be a bit careful here because once we get to the last few rows of the data frame, if we take I plus 5, then basically we are exceeding the maximum row in the data frame. So the trick to fix that is to take the minimum of I plus 5 and the maximum index in the data frame. So now we just need to store all the entities that appear in these 5 rows into a list. So a trick for doing that is just to call a sum function and merge this list with an empty list. If we print out a few example outputs, we can see that there are quite some duplicated characters in those windows, and those duplicates are not interesting because I'm not interested in analyzing my relationship with myself, so we can just remove those duplicated characters next to each other. And now we actually create the relationships between the characters that are in the window. Basically, we will go through the list and create an edge for all the characters that appear next to each other. So now we just initialize an empty list for the relationships, and then we'll just basically loop through all the unique characters that appear in the window, and then we will create relationships like between the two characters that are appearing next to each other. So we will take the first character as a source and the second character as a target. So that's just the way you define a network. And let's only do this if the length of the character unique list is actually larger than 1. Because if there's only one character, then basically there's no relationship. And let's try this out. Oh, we got an error because we are actually iterating through all the characters in this list, but actually we should only iterate until the second last character, because if we increment the index by 1 here, we will basically exceeding the maximum index of the list. So to fix that, we'll basically only iterate until the second last element in the list. Okay, now this works, and we will basically create a data frame out of this relationships list. And let's take a look at this relationship table. This looks pretty good, right? Now, the last thing that we want to do is to aggregate all the duplicated relationships that we see here. For example, Geralt and Ciri many times have relationships with each other. So we will aggregate all those rows together and create a weight column. So the weight or the value column here basically indicates to us how strong a relationship between the two characters is, and basically how many times the relationship appear in the text. In some cases, we have some reverse relationship between the source and target column, and they are also duplicated relationships, right? So we want to aggregate all of them into only one relationship. So the way we tackle this kind of like reverse order duplication is to sort all the rows column wise, and so we will then be able to identify all the duplications easily. So that is exactly what we want. And for each row, we will create a value for the relationship, basically the weight, as 1. And finally, we just need to group by the source and the target, and then we will take the sum of all the values. So in the end, we will have a value column that indicates how many times this relationship appear in the text according to our definition. Congratulations, we have successfully created a relationship data frame based on the text, but the next part of our project is even more fun. That is to do graph visualization and to do some analysis on the graph. With NetworkX library in Python, we can create a graph based on a pandas data frame. So we'll do NetworkX from pandas edge list, and pandas edge list is actually essentially what we just created. So that is a data frame that contains the source and the target. So every edge in the network will have two components, so the source node and the target node. So here we just pass in our relationship data frame and specify the source and target column. And we also want to create the edge attribute. So the edge attribute is different kind of properties of the edge. So here we have one property that is the value. So we will input the value here for the edge attributes. But if we have multiple properties, we can make a list here of the column names. With NetworkX, we can also visualize graphs very easily. There are several layouts that they provide for us to visualize a graph. For now, we will use the Kamada Kawaii layout because I think it looks most reasonable for this graph. So it's quite simple. We just define a layout as positions for the nodes, and then we will just call a draw function on the graph with the labels is true, and then the node color and the position as the position that we just defined. If we do plot show, oops, we got an error here that says no module named SciPy. So it seems that we need this module in order for this layout function to work. So we'll go ahead and open the terminal and install this SciPy module. So here we are, we got a graph of all the characters in the first book of the series. We can also change the figure size, so I will increase the figure size a little bit to make it a bit bigger. Honestly, you can see that it's not a great graph, right? The labels are very hard to see. It is very static because you cannot zoom in, you cannot interact with it. The edges are kind of like just like intersect with each other. It kind of sucks. So I'll show you now how to visualize this graph with PyVis. So we just need to import the network module in the PyVis network. Then we just initialize a network. We can specify here the notebook equals to true because we want to see it in our notebook. And we define the width and the height of the figure. And we also can customize the background color and the font color for the labels. And the nice thing is PyVis can interface with the NetworkX library. So if we call from NX method and pass in our G graph here, we do a show function here and create an HTML for this, then we will see that we have a network that is much nicer. One thing that I still want to customize here is the node size. You can see that we almost cannot see the main characters here in this network. So for now, I will just customize the node size based on the degrees of the node. The degree of a node is defined as the number of connections this node has. Like if we draw a circle around the node and count the number of times the circle touches the edges around the node, then this is the degrees of the node. NetworkX has already done all of this for us, so we just need to store the degree of the nodes in a dictionary. And we can print out this dictionary to see what it looks like. Yeah, here you are. You can see that Garrett has the most degrees. So if everything goes well, Garrett should be the largest node in our graph. Now we just need to use the node degree dictionary and set the node attributes. And we call this attribute the size attribute. PyVis will automatically recognize this size attribute and visualize the size of the node accordingly. We see that Siri, Jennifer, and Dandelion are also the main characters as well. The concept we just touched upon is degree centrality. It is basically based on the assumption that the nodes that have many connections are the most important nodes. However, there are many other centrality measures. For example, closeness centrality measures how long it will take to spread information from one node to all other nodes sequentially. Betweenness centrality measures how often a node acts as a bridge along the shortest path between the two other nodes. So this could be thought of as someone in your friend circle who introduces you with another circle of friends, and they act as a bridge between the two friend circles. So now let's go ahead and see what are the most important characters in The Witcher according to those centrality measures. So the first one we already saw, but now we just basically call the degree centrality method here. This will provide us with a scaled value between 0 and 1 measuring the degree centrality of a node. And let's sort all the items in this dictionary from high to low. So now you can see that indeed Garrett, Siri, Jennifer, and Dandelion are the 4 most important characters, and that matched what we just saw on the graph before. If we do betweenness centrality, then we will see that, yeah, basically we have the same results. And how about closeness centrality? It also gives us sort of the same results. However, the difference between Garrett and other characters seem to be much smaller. Yeah, this is a very dense network, it seems. And finally, we just save all these centrality measures into the node attributes. This is just for the visualization purpose for the next video. Community detection is a very useful technique in graph analytics. So basically, if we have a social network, we can identify the communities that form this graph, and from that we can get a lot of different insights about the dynamics of the network and how the network, different communities interact with each other. There are several algorithms available for community detection. For this, I will use the Louvain detection algorithm, so we can import the Python Louvain library. And then if we call the best partition function on our graph, then we'll have a dictionary that has all the nodes and which community it belongs to. And then we just set the communities as a node attribute called group. And this group attribute will basically be detected by Pivot, and automatically it will assign different colors for our nodes. And now if we do the same visualization step as we did before, we are left with a graph with some colorful colors that marks different communities, and we can see that there are quite some different communities here. We have one community for Garrett, and we also have a different community for Siri, which also makes a lot of sense to me because throughout the series, Siri and Garrett basically are finding each other. We have a different community for Jennifer. So yeah, this is very nice. To top it all up, a fun analysis we could also do is to analyze the evolution of the character's importance over time, so throughout the book series. To do that, basically we just need to create different graphs for all the different books, and then we see what are the importance of characters in each of the books, and then we plot them on a graph, right? But to be able to do that, we finally need to loop through all the books in our data, basically perform all the steps that we have done in this video. So yeah, I'll go ahead and clean up our notebook and create different functions for different steps that we have done. My idea is that we'll store all those functions that we are going to make into a separate Python file, so that we can import this Python file into our notebook, just to avoid that our notebook would be too big, and if someone wants to use or reuse those functions, they can easily just import that file. So I'll go ahead and create a folder called utils in the lib folder, and in this folder we'll create a functions.py file, another file necessary for building a package in Python called init.py. So I'll make all these functions and write little documentation for them so that other people know what they do. I'll need to speed up the video a little bit here. And also don't forget to import the Python modules we are using. Okay, now this is done. I hope that I didn't break anything. Another thing that we need to be careful with this for loop is that our current book list, so the all books list, is not ordered in the chronological order of the book series. And since we want to analyze the importance of characters in the chronological order, so we'll need to reorder our books in our data folder. I haven't read all of these books by myself, so I have no idea what is the right order to read these books. So I'll go ahead and search on the internet if someone already talks about this. And yeah, so there are some kind of orders that people suggest here. So I'll just rename those books according to the order that we see here. Okay, so now we'll create a books graph list that will store all our graph letter for all the books, and then we will basically do the for loop, and we will create the graph for each of the books and append those graphs into this books graph list. And in the end, we just create a list of degree centrality for all the books, and then basically we just need to plot the degree centrality for example, I put here Geralt, Ciri, Yennefer, Dandelion, and Vesemir. So I think they are the 5 main characters. So let's see what's up with all these characters over time. So you can see that Geralt is almost always the most important characters over time, and also Ciri as well. She's the second main character in the whole series, although she only appeared since the second book of the series, because the first book I think she was not born yet. So this is really interesting. If you're interested in learning more about graph analytics and social network analytics, there are several resources for this. If you've ever learned discrete math or data structures and algorithms, you might have come across a lot of basics of graph. However, if you haven't, a good place to start learning about graph analytics is the Graph Analytics for Big Data course on Coursera. In this course, you will learn all the basics of graph, what is graph, and how to do graph data science with Neo4j, which is the graph database management system. Otherwise, if you just want to stick to using purely Python for now, then going through the NetworkX documentation and tutorials is a great place to start as well. This project series is actually not ending yet. In the next episode, I'll show you how to create a 3D network graph visualization dashboard using Three.js. I'm still in the process of finishing up the project, so fingers crossed. I've also recently started a Discord server to create a community for us where we can help each other in learning data science, creating portfolio projects, and sharing knowledge and advice. The reason I created this Discord server is that I realized that in many videos you guys just posted questions to me about some errors, about some advice, about a lot of things about creating portfolio projects on the comments in the videos, and usually I would miss them, or other people who want to help you or to find information, they also cannot really easily see those questions. So yeah, if you want to join this community, you can find the link in the description down below, and have a nice day. See you next time. Bye!